Hello everybody, this is Jyoti Mayekar. I'm teaching nuclear physics and this is lecture 7. Yeah, so today what we are going to talk about is binding energy and mass defect. By mistake it is made difference there, it is defect. Yeah, okay, so the variation of measured atomic mass from the mass number A is quite significant. The difference between m, that is the measured mass, and A is known as mass defect delta M. For example, mass of helium, it is 4.002603 units. It is slightly greater than the mass number 4. So delta M, mass defect in case of helium, it is positive plus 0.002603 units. In case of oxygen, the mass is 15.994915 units, so it is slightly less than the mass number 16. So mass defect, it is equals to 0.005085 units. That means mass defect can be both positive or negative. It is positive for light and heavy nuclei and it is negative for intermediate nuclei. According to Einstein's theory, E equals to mc square, very famous equation, mass can be considered to be form of energy. So when two nucleons are bound together into a nucleus, a certain quantity of mass disappears as it is converted into its equivalent amount of energy. This particular energy is known as nuclear binding energy. Yeah, so when nucleons they combine to form a nucleus, then the energy which is required, that is called as nuclear binding energy, or it can also be defined in other way, the energy, the minimum amount of energy which is required to break the nucleus into its constituent particles, constituent nucleons. Yeah, so either binding energy you can define as the amount of energy which is required to bind the nucleons together inside the nucleus, or you can define uh, binding energy as the minimum energy required to break the nucleus into its constituent particles. Either way, if this binding energy is large, that means the nucleus is highly stable. A nucleus is said to be in the ground state if a nucleus has the minimum possible energy which is equal to its binding energy. And if the energy of the nucleus it is greater than E minimum, then the nucleus is said to be in the excited state. The nucleus dissociates into its constituent particles or nucleons for E equals to 0. So binding energy is equivalent of missing mass. If a nucleus has Z protons and N neutrons and M is mass of nucleons determined experimentally, then for any isolated bound system, binding energy of the nucleus is ZMP. See, inside a nucleus you have protons and neutrons. So mass of that nucleus will be mass of total protons and mass of total neutrons. Suppose mass of one proton it is MP. Total number of protons are Z. So ZMP it will give mass of total protons. Mass of neutrons suppose it is Mn. Total number of neutrons are N. N into Mn will give you mass of total neutrons. And ZMP plus Nmn it will give you mass of the nucleus minus M. It is the mass which we have calculated experimentally into C square. This will give you energy in joules. And as in case of nuclear physics, mostly we find out the energy in terms of million electron volt. We can convert this into million electron volt. Okay. So we know that 1 AMU it is equivalent to 931 MeV. In my earlier lecture, I have derived that 1 atomic mass unit it is equivalent to 931 million electron volt. So here binding energy in million electron volt will be difference in mass. That difference in mass it will be in AMU. That multiplied by 931 it will give you energy, binding energy in million electron volt. Generally we find out binding energy in million electron volt. So nucleus disintegrates on its own provided binding energy less than 0. Otherwise, the nucleus is stable for binding energy greater than 0. In this case, one has to supply, suppose binding energy it is greater than 0, then you will have to supply energy externally to break the nucleus into its constituent particles. If binding energy it is less than 0, it will happen on its own spontaneously. Generally, binding energies are very high. For stable nuclei, it ranges from 2.224 MeV, it is the binding energy for deuterium, to 1640 MeV for bismuth. Thank you so much for watching.